So this is 3.1 Boolean expressions. It says it should take around 45 minutes. Hopefully we're able to do it less than 45 minutes. Okay, we've actually talked about Boolean values already in this class. And when you think of Boolean values, just think of true and false, yes and no, on and off, 1 and 0. All right, so Boolean variables or expressions can only have true or false values. There's only 2 values it can have. Okay, the operators equals the double equal to sign, and then we have an exclamation mark, question, exclamation point. I always mix up the two. I always have to think question mark, exclamation point. So that's an exclamation point equals. Okay, so the double equal to just is equals, because we use the 1 equal sign as an assignment operator. So we have to create something different. On the AP Computer Science Principles exam, they use an arrow pointing from left to right as an assignment operator. And instead of using a double equal to sign, they use 1 equals, which is like pretty confusing. But my students at the end of when they're finally out to take the AP exam, they ask a lot of questions regarding that. But it says the operators equals equals and exclamation point equals, that's not equal, can be used to compare values. Okay, so if I were looking to see if is 3 equal to 3, if I use 3 equals 3, it would return true. If I used 3 exclamation point equals 3, it would return false. Okay, so equals equals is yes, that's equal to each other. Not equal to is exclamation point equals. And they can be used to compare 2 different values. They return true or false. And as I just mentioned, 1 equal sign changes the value of a variable. It's the assignment operator that we use if we're creating a variable and we assign a new variable the value of 3. That's why I try to be very careful. Instead of saying like, oh, we create a new variable and it equals 3, I try to correct myself and say it assigns the value of. Okay. So a certain value without changing it. And it says, watch the following video, and you can watch it in your own time, but it's a quick video and it goes through and shows how assignment operators work. And then all the way through here, if you look at this code right here, this shows you everything and we can walk through it. But an integer is assigned the value of 15. Y is assigned the value of 44, Z 44. We create a new dog from a class called Fido. And then we create a new dog called Oreo. And then we have a dog called Friend and assigned it Oreo. So then it asks, right, is X equal to Y? If I were to print that out, X equals Y, the answer would be false. It would print out false. If I were to print out Y equals Z, it would print out true. Is Fido equal to Oreo? The answer would be false. Is Oreo equal to Friend? The answer would be true. All right. This says the following code shows how equals equal is used with primitive types like int. Okay, we talked about primitive data types already. What will the code print out? Try to guess before you run it. Note that 1 equal sign is the assignment operator and 2 is for testing values. All right, so let's look at this. We have a class called bool test for Boolean test. We have our main method. We have an integer, a variable called age, and we've assigned the value 15. And then we have an int called year, and we've assigned it the value 14. It says, will this print out true or false? Is age equal to year? It should print out false because 15 does not equal 14. And then we changed what year was. We assigned year now the value of 15. And then it asked the same question again. Will this print true or false? We've changed the value of 15 of year to 15. So age and year should both equal 15. Is 15 equal to 15? This should be true. So right above, this should print false. This should print true. And then it says system.out.println age is not equal to year. Is age not equal to year? Well, they are equal to each other, so it's not true. This would print out false. So it should print out false, true, false. That's my prediction. Let's run it. False, true, false. It says we can also use equals equals and exclamation point equals to test if two reference values like turtle and string objects refer to the same object, right? Just because you create a new object, that object is not the same, even though it comes from the same class, it's not the same object. In the figure below, we're creating two separate turtle objects. We finally found different names for our turtles. We have Juan and Mia. Okay, they do not refer to the same object or turtle. Then we create a reference variable called friend that is set to Mia. The turtle Mia will have two ways, references or aliases, to name her. She is both Mia and friend. And these variables refer to the same object, the same turtle memory. If two reference variables refer to the same object, like the turtle on the right in the image below, the test with equals equals will return true, which you can see in the code below. So very similar to what we just did. Nothing new, not a new concept. Okay, we have a turtle. We create it called Juan. Create a new turtle called Mia. So we have Juan and we have Mia. But notice if we also create a turtle called Mia or called friend and assign it the value of Mia, right? This is really just, you're not creating a new turtle. You're just creating a new reference for it. So it could be called Mia and called friend. There's Juan and there's Mia. All right, what will the code print out? Try to guess before you run it. We've made two imports here. And then we're creating a new class called BoolTestRef. Not sure what this is going to refer to, but we have our main method. And then we create a world, right? It's 300 by 300. Inside that world, we have Juan and we have Mia, two turtles. Will these print out true or false? System.out.println Juan is equal to Mia. Will Juan print out equal to Mia? Is that true? The answer is no, it is false. And then we have turtle friend is assigned Mia. Will friend print out true or false? Friend is equal to Mia. That should print out true. So my prediction is false, true. Let's see if it works. False, true. All right, 312 relational operators. So we talked about mathematical operators before, arithmetic operators, as they're called as well, back when we were doing different operations like plus, minus, forward slash, and then the asterisk, and then the modulo. These are different types of operators called relational operators. There are really three main types of operators. You have your mathematical operators, your relational operators, and your logical operators. All right, so it says the relational operators below in Java are used to compare numeric values or arithmetic expressions. Although some programming languages allow using relational operators like less than to compare strings, Java only uses these operators for numbers and uses the string methods compare to and equals. So as this is nothing new, we've already gone through this. We talked about it in the methods from last week. But when we're talking about comparing two strings, we would use compare to or equals. But for other primitive types, we're using less than, greater than, less than or equal to, greater than or equal to, and we already talked about these two. All right. If you have trouble telling less than or greater than apart, think of a number line and the arrows. I kind of laughed, but that's not necessarily something that everyone knows. But you know, the less than symbol and the greater than symbol. All right. Let me read through that. Remember that less than starts with the less than point and greater than starts with the open wide greater than sign. Okay, when I was a kid, I learned it in 2nd grade. My daughter's learning this as well. And you guys might remember this. It's the mouth, whatever way the mouth opens up to is greater than, right? The way my 2nd grade teacher taught me was with M&Ms. Do you want more M&Ms or less M&Ms? And the mouth would open towards the more M&Ms. All right, and then we have less than or equal to, greater than or equal to. I'm going to make an assumption there that we can move forward. All right, so we have our class. This is called bool test 2. And then we have our main method. It says try to guess what happens here. I have an int age, which is assigned the value of 15, int year, assigned the value of 14. How will these print out? All right, so age is less than year. Is that true or false? I'm going to say that is false because age is 15 and year is 14. That's false. Is age greater than year? Yeah, that's true. Just making comments in the side so that way I don't forget my predictions. Okay, is age less than or equal to year plus 1? Well, age is 15. Year plus 1 would be 14 plus 1 is 15. Is it less than or equal to? Well, it's not less than, but it is equal to, so it'd be true. Okay. If I had age minus 1, this would be 15 minus 1 is 14. Is 14 greater than or equal to 14? Well, 14 is not greater than 14, but it is equal to, so it should come out as true. Those are my predictions. False, true, true, true. Let's run it. Let's see if this is right. False, true, true, true. All right, looks good. Got my pass. All right, drag the following Boolean expressions from left and drop it to the right. Let's check it in the end. Okay, y is not equal to, or sorry, x is not equal to y. So y does not equal, or x does not equal y. X is greater than 0. So x is positive. X is less than y. I'm sorry, x is less than y. X is less than y. X is greater than y. X equals y. If x is less than 0, then it's negative. And x is greater than or equal to y. All right, so what mine looks like. And then I'm going to run it. Let's check it. And it says you're correct. All right, the modulus or modulo symbol is back. It says here are some Boolean expressions that are very useful in coding, and mod is used in many of them. All right. Yes, this is a common way to test if a number is even, is by dividing a number by 2, and if the remainder is 0, right, then the modulus should return 0. This is a popular way of finding is a number even. So this is a popular way of testing if a number is positive, if it's negative. So if you're ever writing a program and you want to see if something's positive or see if something's negative, these two would be valuable. Test if a number is even by seeing if the remainder is 0 when divided by 2. Test enough if a number is odd by seeing if there is a remainder. All right, you're going to find out if a number is odd. This is just not just code that you would write, but there's also algorithms that you'll learn by reprogramming more that make programming easier. You'll learn different algorithms that exist and just kind of memorize them because you'll use them so often, and be able to, once you have a bunch of algorithms and different expressions memorized, you're able to just quickly write your code. It says test a number if it's a multiple of x, and you can use the modulus symbol, say number, and then remember this returns a remainder, okay, divisible by with no remainder. Try the expressions containing this percentage operator, which is the modulo symbol below, to see how they can be used to check if even or odd numbers. We just did that, so I'm just going to run it. All right, so we went through, for example, I guess actually using it in action. I will talk about this briefly. It says system.out.println, and it says the remainder of age 15 divided by 2. So 15 divided by 2 is the remainder is 1. So we got the divisor. The divisor was 2. So we're using the modulus symbol here. Age 1, age 2. That's how we got 0, 1, and 0. Is 15 even? The way you could tell if it was even, we took the age and we divided by 2 and checked for the remainder. The remainder should be 0 if it's even, right? All even numbers are divisible by 2. So is it equal to 0? Yes. Or sorry, is 15 divided by 2? Do I get a remainder? The answer is false. But if I take 16 and divide it by 2 and find a remainder, should be 0, and you get true. Okay, so 15 is not even, 16 is even. All right, it says the modulo operator has been used quite a bit on the APCSA exam, so you should be familiar with it. Okay, and this is just a recap of what we've already kind of used it for in the past. But these are, I guess the first one is a recap. The other three we'll actually walk through. It says you would use it to get the last digit from an integer number. So you take the number and you're using the modulo symbol 10, and that would give you the last digit on the right, because you're dividing by 10 and then seeing if there's a remainder. Okay, that would give you the last digit on the right. In order to get a number of minutes left when you convert to hours, right, that's a good one. So you take the number and then use the modulo 60. So these are real world practical applications here. Use it whenever you have limit in the value and you need to wrap around to the front if the value goes over the limit. Okay, so if the number divided by the limit, if there is a remainder. All right. Moving forward, it says programming challenge, prime numbers, POGIL. We encourage you to do this activity as POGIL, process-oriented guide inquiry learning, group activity using think, pair, share, collaboration. We're not going to do that. POGIL groups are self-managed teams of 4 students where everyone has a role. If you want to go through that, you can. In this activity, you'll use Boolean expressions to explore prime numbers. We know what prime numbers are: 2, 3, 5, 7, 11, 13, 17. For example, 3 is a prime number because it's only divisible by 1 and itself. no other numbers. Okay, you've learned that in math class. You've learned what prime numbers are. I remember one teacher had a list of prime numbers that went around his entire classroom. Prime numbers are very useful in encryption algorithms because they can be used as keys for encoding and decoding. If you have the key, you can use it to divide a large number that represents something encrypted to decode it. But if you don't have the key, it's very hard to guess the factors of a large number to decode it. If you're curious about this, here's an additional video you can watch. The following program checks if 5 is a prime number by seeing if it is divisible by the numbers 1. It says 1 through 5. Run the code and then answer the following questions. Okay, is 5 a prime number? What Boolean tests determine that a number is prime? Change the number to 6 and add more Boolean expressions to determine if 6 is prime. Is 6 prime? 6 is not prime. All right. So we'll run this. Okay. And it starts off by just saying a prime number is only divisible by 1 in itself. What it wants us to do is go down this checklist. Okay. So is 5 a prime number? We'll run this. Divisible by 5. Experiment with the code, changing the value of numbers and adding more print statements with Boolean expressions to determine if the numbers 5, 6, and 7 are prime. Are all odd numbers prime? No. Are all even numbers not prime? So we'll copy this code. And I'll paste it here. Divisible by 6. And we'll say divisible by 7. I think it wants us to do 8 as well. Oh, 5, 6, and 7. Okay. So divisible by 7, I guess, int number. If we want to start off here and say, I don't know, 7. And if we run it, okay, is 7 divisible by 1 up to 7? Is it divisible by 1? True. Divisible by 2? False. 3 false. 4 false. 5 false. 6 false. 7 false. Or 7's true. I'm sorry. So is 7 prime? Yes, because only divisible by 1 and itself. All right. And we've went through and created that. The summary, we talked about the double equals to as well as the not equals to. So equal to, not equal to. The arithmetic expression values can be compared using relational operators. We talked about these. And an expression involving relational operators evaluates to a Boolean value of true or false. This game is back. We used it before with strings. Okay. When we were trying to see, if you remember, right, we're using it for strings. This would be, what would the substring 1, 3? It would print out 1, 2, and then stop at 3. Fish would go 0, 1, 2, 3. Okay, and creates a game for us. But it wants us to click on relational, and we're going to test this. We're going to play with this a little bit. And this says x is greater than or equal to 93. Which one actually fits? And the answer would be none. Which of these are greater than or equal to 2? All of them. Which is greater than 19? All of them. Which is less than 32? All of them. Less than 32, 9. All right, so that's just a game that someone created that allows us to continue to explore conditionals. I'm sorry, relational agreements, but then eventually we'll be pushing on conditionals in the next lesson. All right, 7 out of 7 activities on this page completed. It says completed, well done. And that was 3.1 Boolean expressions.